German engineers studied the wreckage. They measured, calculated, tried to copy. They couldn't. 6 American aircraft were so brilliantly engineered that even when enemies knew how they worked, they couldn't match them. This is American innovation that dominated the skies. Boeing B-17 Flying Fortress. Boeing engineer Edward Curtis Wells had one revolutionary idea in 1934. What if a bomber could defend itself? He created the world's first bomber with 13.50 caliber machine guns covering every angle. No blind spots. But the real genius was invisible. Semi-monocoque construction. The skin itself carried structural load. Blow massive holes in it, and the remaining structure redistributed stress. German inline engines? One coolant leak, they died. The B-17's Wright R-1820 Cyclone? 9 radial cylinders. Destroy 3, it ran on 6. Boeing built 12,731 B-17s. Germans captured intact examples, studied every rivet, tried to copy it with the HE-177. Result? 1,100 aircraft. Most caught fire from coupled engine design flaws they never fixed. The B-17 survived because American engineers understood redundancy and load distribution at levels Germany never reached. When German pilots said, "We hit them and they don't fall," they weren't describing luck. They were describing superior engineering that made the aircraft nearly indestructible. North American P-51 Mustang. 1940. British contract. Deadline? Design and build a prototype fighter in 120 days. Designer Edgar Schmood delivered in 117 days, but the genius was the laminar flow wing. Schmood designed an airfoil where air flowed smoothly instead of becoming turbulent. This reduced drag by 30%. Less drag meant 40% better fuel economy. Better fuel economy meant 1,650-mile range. That's Berlin and back. Then they swapped the Allison engine for a Rolls-Royce Merlin, completely redesigning the cooling system and supercharger. The result? The fastest, longest-range fighter in the world. North American built 15,000 P-51s in 4 years, 10 Mustangs per day, every day. German Bf-109 factories? Maybe 3 per day, under constant bombing. The Mustang's laminar wing was so advanced that Germany couldn't copy it. They tried with the TA-152. By the time it flew, 15,000 Mustangs were already hunting over Germany. American engineering moved faster than the enemy could respond. 2 down, 4 more masterpieces coming. Subscribe now if you appreciate real innovation. Hit that like button, it genuinely helps. Douglas C-47 Skytrain. Here's genius through simplicity. Douglas took their DC-3 civilian airliner, added a cargo door, and reinforced floor. That's it. Why brilliant? The DC-3 was already flying commercially since 1935. Already proven, already reliable, already in production. When war came, no testing needed, no debugging, just build. 2 Pratt & Whitney R1830 engines, the same engines used on dozens of other aircraft. Broken engine? Replace it in hours. Spare parts everywhere. The airframe could land on grass, dirt, bomb-damaged runways. Pilots said the aircraft communicated when it was about to stall. Douglas built one C-47 every 44 minutes at peak production. Every 44 minutes, a complete aircraft. Germany's Ju-52 equivalent? Slower, carried less, needed 3 engines. Total production? 4,800. Douglas made 10,174 C-47s. Eisenhower listed 4 tools that won the war: bazooka, jeep, atom bomb, and the C-47. One was a barely modified airliner. That's how good the original design was. American manufacturing at its peak. Proven design, complete standardization, unstoppable production scale. Boeing B-29 Superfortress. 1938. Boeing asked, what if we designed the bomber of 1950, but build it in 1943? Pressurized cabin. Crews flew at 35,000 feet in shirt sleeves. No other bomber had this. Remote-controlled gun turrets with General Electric's central fire control computer calculating bullet drop, lead angle, temperature, altitude automatically. This was 1940s artificial intelligence. 4 Wright R3350 engines, 2,200 horsepower each, 18 cylinders per engine, the most powerful in mass production. They ran so hot they caught fire during testing. Boeing engineered automatic cowl flaps and fire suppression until it worked. The B-29 cost $3 billion to develop, more than the Manhattan Project. 55,000 engineering drawings, 55,000 parts per aircraft, all fitting precisely. Boeing built 3,970 of them. German intelligence photographed it, analyzed it, realized they had no counter. Americans built a bomber flying higher, faster, farther than anything Germany could design, with crews sitting in comfort. The technological gap was unbridgeable. This wasn't just superior. This was an entire generation ahead. Grumman F6F Hellcat. Grumman's philosophy: build aircraft mechanics can fix on a pitching carrier deck at night. The Hellcat was intentionally simple. Wings folded with one hydraulic actuator. Engine cowling held with quick-release fasteners removed in 90 seconds. Entire engine swapped in 45 minutes. Compared to the Zero needing hours of delicate work, or the BF-109 requiring specialized tools. But simple wasn't primitive. Pratt & Whitney R2800 Double Wasp, most reliable radial engine ever built. Self-sealing fuel tanks, armor protecting the pilot, structure surviving carrier landings that destroyed other fighters. Grumman built 12,275 Hellcats in 30 months. That's 13 fighters per day, every day, for 2.5 years. The 19-to-1 kill ratio wasn't just pilot skill, it was engineering reliability. When a Hellcat entered combat, everything worked. Every time. Guns fired, engine ran, structure held. Japanese and German aircraft couldn't promise that. American reliability engineering won as much as American pilots did. Vought F4U Corsair. The Navy wanted a 13-foot propeller for maximum power. Problem? It would hit the carrier deck. Designer Rex Beisel solution? The inverted gull-wing. Bend the wing down, then back up at the landing gear. Raise the fuselage without impossibly long landing gear. Bonus? The wing angle reduced drag where it met the fuselage. Air flowed smoothly. Unintentional genius. Pratt & Whitney R2800, 2,250 horsepower driving that massive propeller. Result? 417 miles per hour, faster than almost every Axis fighter. The wings use spot-welded construction, lighter and stronger than riveting. Landing gear rotated 90 degrees to fit flat in the wing. Here's the proof of quality. Corsairs flew frontline combat 1942 to 1965. 23 years. It outlasted World War II, Korea, and kept going. Why? The engineering was fundamentally sound. Overbuilt airframe, reliable engine, maintainable systems. Vought built 12,571. Germany's TA-152 answer? 43 total. The Corsair proved American engineering created aircraft dominating for decades, not just years. If this showed you the brilliance behind American air superiority, subscribe now. Hit like if you want more technical breakdowns. Comment, which aircraft's engineering impressed you most? Let's discuss American innovation.